morning, myself Professor Reddy, Head Department of Bioinformatics. Today I would like to tell you about this topic DNA sequence alignment. So before entering into the actual topic, so let us see the vision of the Department of Bioinformatics. So the vision statement goes like this. So the vision of the Department of Bioinformatics, it is like to be a leading innovation center in bioinformatics, offering a dynamic curriculum which is aimed at producing globally competent, employable, entrepreneurial and research professionals with ethical values capable of addressing challenges in multiple domains. So, if you go through the vision statement, it clearly states that Department of Bioinformatics, it is a leading innovation center which is mainly aimed at producing globally competent, employable, entrepreneurial and research professionals with ethical values and who are capable of addressing challenges in multiple domains. Coming to the mission statement, so we have Department of Bioinformatics has 3 mission statements. The first statement is offering the state of art curriculum with skill based practices in teaching and learning to equip bioinformatics students for employment. Coming to the mission statement 2, providing advanced computational and laboratory resources to prepare students for higher education and research. Coming to the mission statement 3, shaping well-rounded professionals with ethical values, leadership qualities and teamwork skills for lifelong learning. So, if you go through the mission statement, 3 mission statements, the first mission statement mainly focusing on creating employment for the graduates. Coming to the mission statement 2, it mainly focuses on higher education and research. Coming to the mission statement 3, it mainly focuses on developing leadership qualities and building teamwork with ethical values, which is a practice throughout lifelong. So, the 3 mission statement, the first statement mainly focuses on employment opportunity, creating employment opportunities. Mission statement 2 mainly focuses on higher education and research. Mission statement 3 mainly focuses on entrepreneurial skills and then leadership qualities and building teamwork skills, which are very much essential for lifelong learning. Coming to the program educational objectives, the Department of Bioinformatics has 3 PEOs, program educational objectives. Coming to the PEO statement 1, it emphasizes, statement is as follows: identify and analyze biological data using bioinformatics tools to design drugs through structural biology approaches. So, coming to the Bloom's taxonomy, there are 6 levels of Bloom's taxonomy, starting with remembering, understanding, applying, analyzing, creating and then evaluating. So, here the PO, program educational objective statement 1 mainly focuses on identifying and analyzing in the biological databases and with the help of informatic tools mainly to design drugs through structural biology approaches. Coming to the program educational objective 2, it is as follows: develop predictive solutions to explore biological processes focusing on genomics, proteomics and metabolomics. So, program educational objective 2 mainly focuses on developing solutions to explore biological processes focusing mainly on genomics, proteomics and then metabolomics. Coming to the program educational objective 3, it demonstrates technical expertise, communication and entrepreneurship to foster professional growth and interdisciplinary leadership. So, program educational objective 3 mainly focuses on technical expertise, communication and entrepreneurship to foster professional growth and interdisciplinary leadership. Coming to the program specific outcomes. So, Department of Bioinformatics has 2 PSOs, program specific outcome 1, it is as follows: develop informatics algorithms and tools to address key challenges in biotechnology including genome assembly, protein structure prediction and molecular docking. So, program specific outcome 1 mainly focuses on developing bioinformatics algorithms and computational tools to address key challenges in the field of biotechnology including genome assembly, protein structure. As we know, like protein has 4 conformations: primary, secondary, tertiary, quaternary structure and then followed by molecular docking. Coming to the program specific outcome 2, PSO2, facilitate the use of biological databases and computational tools to analyze and interpret data, providing domain expertise to support research in life sciences. So, this is all about vision, mission, program educational objectives and then program specific outcomes. Coming to the contents, so first we will see what is an alignment and what are the different types of alignments, what is dynamic programming, followed by what is global alignment and then followed by local alignment, and finally we are going to summarize. So, the main objective of this course algorithms in bioinformatics is to equip students with computational skills and to help them use computational methods to study, organize, analyze and interpret biological information at molecular, genetic and genomic levels. So, coming to the outcome, student will be able to query biological data from databases, interpret and model biological information and apply this to the solution of biological problems in any arena involving molecular data. So, coming to the alignment. Alignment mainly used to uncover homologies between sequences combined with phylogenetic studies, and they can also be used for determining orthologous and paralogous relationship. So, here we have two types of alignments. The first one is the global alignment and then the second one is the local alignment. Basing on the number of sequences we have, so we have two types of alignments, right. So, the first one is pairwise alignment and the second one is multiple sequence alignment. So, when the number of sequences are 2, we call it as pairwise alignment. When the number of sequences are greater than 2, we call it as multiple sequence alignment. So, pairwise sequence alignment is again of two types. So, pairwise sequence alignment is of two types. The first one is global alignment and the second one is local alignment. So, coming to this global alignment. So, what is this global alignment? So, global alignment is nothing but alignment of a pair of sequences along their entire length. So, that is from the beginning of the sequence to the end of the sequence, and the algorithm which is used for carrying out this global alignment is Needleman-Wunsch algorithm. So, coming to the second type of alignment, that is local alignment. So, local alignment is nothing but alignment of a pair of sequences along their conserved regions, and it makes use of the algorithm, that is Smith-Waterman algorithm. So, next is dynamic programming. So, what is dynamic programming? So, dynamic programming is defined as alignment of a pair of sequences either globally or locally using Needleman-Wunsch algorithm or Smith-Waterman algorithm. So, dynamic programming is defined as alignment of a pair of sequences either globally or locally using Needleman-Wunsch algorithm or Smith-Waterman algorithm. So, dynamic programming is mainly meant for solving complex problems by breaking them into simpler sub problems. So, dynamic programming mainly focuses on solving complex problems by breaking them into simpler sub problems. So, Needleman-Wunsch was the first to propose this method, and this Needleman-Wunsch algorithm is mainly used for global alignment. Needleman-Wunsch algorithm is mainly used for global alignment, and it mainly focuses on maximizing a score of similarity to give maximum match. So, for us to perform this global alignment, so minimum we need two sequences, sequence 1 and 2. So, in between these two sequences we can carry out this global alignment by using Needleman-Wunsch algorithm, and here while performing this dynamic programming, so we are going to assign values for match, positive value, and then mismatch, some negative value, and then gap, negative value. So, maximum match indicates largest number of nucleotides that can be matched with others. So, which implies that quantify sequence similarity between the two sequences. So, dynamic programming in sequence alignment. So, there are three steps. The first one is the initialization step, second step is the matrix filling, and the last step is the traceback step. So, in the dynamic programming there are three steps. The first step is initialization step, second step is matrix filling, and the last step is performing traceback. Coming to the first step, the first step in global alignment, which is nothing but dynamic programming approach, is to create a matrix with m plus 1 columns and then n plus 1 rows, where M and N correspond to the size of the sequences which are going to be aligned. So, for us to perform this dynamic programming, so the minimum number of sequences we require is 2, right. The first sequence we are going to call it as M and the second sequence we are going to call it as N. So, we are going to plot first sequence along rows and the second sequence along columns. As we all know, rows are always horizontal and then columns are always vertical. So, second step in this dynamic programming is the matrix filling. So, once the initialization step is done, then we will proceed with the second step, that is filling the matrix table with values. So, here in this matrix filling step, we are going to fill the matrix with the highest possible score with the help of this algorithm which was proposed by Needleman and Wunsch. And later, to align with the diagonal, align in the next position. Align in half diagonal requires insertion of corresponding gaps. And once the matrix filling is completed, and the last step is the trace back. So, while doing this trace back step, we are going to align sequence 1 with the sequence 2, where we have assumed sequence 1 as M and then sequence 2 as N. So, here in this trace back step, we are going to align the sequence 1 with the sequence 2. So, in the process we are going to just follow this step where we have filled the entire matrix table with the numericals by using this Needleman-Wunsch algorithm. Global alignment via dynamic programming. So, as we have discussed in the previous slide, so dynamic programming is simply defined as alignment of a pair of sequences either globally or locally using Needleman-Wunsch algorithm or Smith-Waterman algorithm. So, in this process, the first step is initialization step, second step is matrix filling and the last step is trace back step. In this trace back step, we are going to align sequence 1 with the sequence 2. So, here in this first column and first row will be empty, which we call it as the origin. We are going to call it as origin. So, origin is a point in the graph where the x coordinate will be 0 as well as the y coordinate will be 0. So, along x axis we are going to plot one sequence, along y axis we are going to plot the second sequence, and we are going to align sequence 1 with the sequence 2. So, for this we can align it through two ways, that is global alignment and then local alignment, where global alignment is done through this Needleman-Wunsch algorithm and local alignment is carried out by using Smith-Waterman algorithm. And the first step is initialization step, where we are going to initially fill all the values, right. So, first row and first column will be 0, we call it as the origin, then fill first row and first column with gap penalty multiples. Here we are going to assign values, that is for match we are going to assign positive value, and similarly for mismatch negative value, and similarly for gap negative value. So, first filling the first column, and so once first column and first row is made 0, then start filling first row and then first column with gap penalty values. While filling the matrix, there are 3 possible values, that is change in row, change in column and then change in row and column. So, all these 3 conditions they are clearly specified in Needleman-Wunsch algorithm, right. First one is change in row, second one is change in column, and diagonal indicates change in both row and column. So, when do we call an alignment as the ideal alignment means? So, if we are able to show match, second one mismatch and then gap. So, an ideal alignment is the one which will have this matches, mismatches and then gaps. So, this is possible only through this diagonal. So, initially we are going to give values, and then so here the value which was given for match is positive value of 1, and for mismatch negative value of -1 and then gap of -2. So, this is what we call it as the initialization. So, in the initialization step, so match value will be assigned a positive value of 1, mismatch value is assigned a negative value of -1 and then gap is assigned a negative value of -2. So, here in the dynamic programming, global alignment is carried out through this Needleman-Wunsch algorithm. So, what is this Needleman-Wunsch algorithm? So, Needleman-Wunsch algorithm is the algorithm which was proposed by Needleman and Wunsch, and they have proposed this algorithm while carrying out this global alignment. the 3 conditions which they have proposed, that is right. So, let us take 2 sequences, let us name it as sequence 1 along x axis and then sequence 2 along y axis. Sequences which are plotted along x axis we call them as rows, and then sequence which is plotted along y axis we call it as columns. So, rows are always horizontal and columns are always vertical, right. Rows are assigned with I and then columns are assigned with j. Rows are always horizontal, that is I is plotted along x axis, columns are always along vertical, so j is plotted along y axis. So, the 3 conditions specified by this Needleman-Wunsch are, so the first one, as you know, like I it is row and then j it is column. So, I minus 1 indicates change in row, similarly j minus 1 indicates change in column. So, that is nothing but across diagonal. So, diagonal indicates change in row, that is denoted by I minus 1, similarly change in column which is denoted by j minus 1. So, one of the condition proposed by this Needleman-Wunsch algorithm, that is when both row and column are subjected to a change, we call it as I minus 1 comma j minus 1 plus s indicates sigma or summation. So, where I indicates rows and then j indicates columns, which implies rows are plotted along x axis and then columns are plotted along y axis. So, the second condition defined by this Needleman-Wunsch algorithm is I minus 1 comma j, which implies I, as we know, like I denotes rows, that is rows are subjected to a change, whereas column is as it is status quo, that is change in row, right. And the third condition proposed by the Needleman-Wunsch algorithm, that is I denotes rows, that is constant, where j is subjected to a change, which implies column change. So, the 3 conditions proposed by Needleman-Wunsch algorithm are, the first one is both row and column subjected to a change, that is I minus 1 j minus 1. Similarly, the second one is row is subjected to a change by column is constant. The third condition is row is constant, column is subjected to a change. Once the values are calculated along these 3 orientation, both change in row and column, change in row as well as change in column, once all these 3 values are calculated, then we need to pick the maximum of the 3, which is subjected to boundary conditions, that is I which indicates rows and j which indicates columns is the substitution score for residues I and j, and g is the gap penalty. As we have seen in the previous slide, gap is assigned a value of minus 2, match is assigned a positive value of plus 1, mismatch is assigned a negative value of 1. So, we consider all possible pairs of residues from 2 sequences, which gives rise to 2-dimensional matrix. When the number of sequences are 2, we call it as 2 into D. When the number of sequences are 3, we call it as 3 into D. When the number of sequences are n, we call it as n into D, where D denotes dimension. So, when the number of sequences are 2, we call it as 2D matrix. When the number of sequences are 3, we call it as 3D matrix. When the number of sequences are n, when we call it as n into D matrix. So, we will have 2 matrices, the score matrix and then the traceable matrix. Here the Needleman-Wunsch algorithm consists of 3 steps. So, the first step is we call it as the initialization, second step is the calculation of scores, and third step is the traceback. So, in the process of doing this third step traceback, we are trying to align sequence 1 with sequence 2. It can be done in 2 ways, that is either it is global alignment or it can all be local alignment. So, if you are doing global alignment, we will use Needleman-Wunsch algorithm. If you are doing local alignment, then we are going to use Smith-Waterman algorithm. So, the 3 steps, the first step we call it as initialization of step, where we will be assigning value for match of positive value, mismatch negative value, and then gap negative value. We call it as initialization. Once the values are initialized, then we are going to calculate values for each and every box in the matrix. So, once all the values are calculated across the entire matrix, the last step is nothing but the traceback. So, in the traceback step, so we are going to align one sequence with the another sequence. So, once this traceback step is done, then you can see that both the sequences are aligned, either they are aligned globally or locally. If it is global alignment, then we are going to make use of this Needleman-Wunsch algorithm. So, if it is local alignment, we are going to make use of Smith-Waterman algorithm. So, let us see a small problem especially for this global alignment. So, here the two sequences are, the first sequence is the size of the sequence 1 is of 4 characters. Similarly, the size of the second sequence is 3 characters. So, let us call them as string 1, right, where the 4 characters are A and then C, and let us take the second string, the size of it is of 3 characters length, that is AGC. So, sequence 1 consisting of 4 characters, sequence 2 consisting of 3 characters. So, here we are going to perform global alignment. Now, we are going to perform global alignment, and the algorithm which is used for carrying out this global alignment is Needleman-Wunsch algorithm. Needleman-Wunsch algorithm. So, as we have seen in the previous slide, it consists of 3 steps. The first step is initialization step, and the second step is matrix filling, and last step is traceback. So, let us see this first step, that is initialization step. So, the algorithm which is used for carrying out this global alignment is Needleman-Wunsch algorithm. So, as we have seen in the previous slide, Needleman-Wunsch algorithm, it specifies 3 conditions, that is f of I comma j equivalent to max of 3 conditions, that is I comma j minus 1 minus d, I minus 1 comma j minus d, I minus 1 comma j minus 1 plus s of x I comma y j. So, Needleman-Wunsch algorithm has proposed 3 conditions. First condition is change in column, that is j minus 1, second condition is change in row, that is I minus 1, and third condition is change in both row and column, that is denoted by I minus 1 comma j minus 1, where I denotes rows, j denotes columns, and d is the gap penalty. D is the gap penalty. I denotes rows, j denotes columns, and then d indicates gap penalty. So, in the initialization step, so here gap, right, match is assigned a value of 2, mismatch minus 1, and then gap of minus 2. So, in the initialization step, so the first row and first column we call it as initialization matrix. Here it is 0 comma 0, 0 comma 0, the first step, right. So, the gap value assigned here it is minus 2. So, as you move forward by one step, the gap value is minus 2. So, as you move the second step, the gap value is multiple of 2, that is minus 4, and third gap it is minus 6, and fourth gap it is minus 8. So, this is what we call it as initialization step. See, this is along rows which are horizontal, and coming to this columns which are vertical. So, initially one gap it is minus 2, second gap it is minus 4, and third gap it is minus 6. The first step is the initialization step. So, in the initialization step, so the first row and first column we have initialized at 0 comma 0, which indicates, so row coordinate is 0 as well as column coordinate is 0. So, coming to this, so as you move one step forward, as we have initialized with a gap value of minus 2. So, one step forward, that is minus 2. So, second step it is minus 4, third step minus 6, and then fourth step it is minus 8. Similarly, along columns, so one step it is minus 2, second step it is minus 4, and third step it is minus 6. So, this is what we call it as the initialization step. So, coming to this second step, that is fill in the matrix with the values. So, as we see this algorithm proposed by Needleman-Wunsch algorithm, so the 3 conditions specified by this Needleman-Wunsch are change in column, change in row, as well as change in both row and column, right. So, as we see the LHS, we call it as f of I comma j. So, on the right hand side we have maximum of any one of these three conditions. So, let us calculate the value, all three values across three directions, change in column, change in row, both change in row and column, and then find out the maximum of the three values and then assign that value to that particular box. So, let us calculate the values for each and every box. So, here it is the size of the sequence 1 is 4 characters and the size of the string, that is sequence 2, is 3 characters. So, in total it is 4 into 3 matrix, which comes to around 12. So, it is a matrix table where we need to calculate values for 12 cells. So, let us start calculating the value from first cell and then let us complete it till the 12th cell. So, this is the second step, we call it as calculation of values, filling up the cells in the matrix table. So, coming to this cell, so the address given to this cell, it is f of I comma j, that is the LHS of this Needleman-Wunsch algorithm. So, as we move up, there is change in the row. So, let us number the rows. This is the 0th column, first column, second column, third column and then fourth column. Similarly, let us number the rows. This is the 0th row, first row, second row as well as third row. 0th row, first row, second row and then third row. So, as we move up from this box to this cell, so there is change in the row, that is here initially row value is 1. So, as we move up, row value is becoming 0. So, it is as simple as 1 minus 1 is 0. So, as we move up from this box to this box, there is change in the row by I minus 1, but whereas column it is as it is. So, this is nothing but the second condition, I minus 1 comma j. So, the value in the I minus 1 comma j box is minus 2 and then minus d is minus 2. So, finally, it comes to minus 4. Similarly, let us calculate the value from the change in the column. So, the address of this box is f of I comma j. As we move to the left, then column is, so what is the column number for this particular cell? It is 1. So, as we move to the left, the column number is becoming 0. So, that it is as simple as column is subjected to a change of 1, that is minus 1. So, the address of this box is I comma j. So, as we move to the left, then I comma j minus 1. So, the value in the I comma j minus 1 box is I comma j minus 1 and then minus d. So, the value in the I comma j minus 1 is minus 2 and gap is minus 2. So, the value comes to minus 4. So, change in row is giving us a value of minus 4, change in column is giving us a value of minus 4. So, next is the third direction, that is change in both row and column. So, as we move diagonally, then so the values in the diagonal box, that is I minus 1 comma j minus 1 is 0 comma 0 and then so the value of this I minus 1 comma j minus 1 is 0 plus S stands for sigma or summation. So, what are the two coordinates? Along x axis we are plotting rows, along y axis we are plotting columns. So, for this particular cell, the row coordinate is A, similarly the column coordinate is A, right. So, row coordinate is A and then column coordinate is also A. So, A versus A indicates match. So, the value which we have assigned for match is 1. So, I minus 1 comma j minus 1 is 0, I minus 1 comma j minus 1 is 0 plus row coordinate is A and column coordinate is A. So, it is match, positive value of 1. So, from the diagonal direction the value is 1. So, change in row is giving us a value of minus 4, change in column is giving us a value of minus 4, change in both row and column is giving us a value of 1. So, change in row minus 4, change in column minus 4, change in both row and column it is 1. So, the maximum of these three is 1. Here this particular box is assigned value of 1 and the direction. So, this particular box value assigned 1 is from the diagonal direction, which implies change in both row and column. Next, coming to the second box, the address for this particular box is again f of I comma j. So, as we move up, there is change in row, that is nothing but I minus 1 comma j. So, the value in the box is minus 4 and gap is minus 2. So, minus 4 minus 2 gives us a value of minus 6. Similarly, when we move to the left, that is change in the column, that is I comma j minus 1. So, the value in the I comma j minus 1 box is 1 and then gap is minus 2. So, minus 1 minus 2. So, diagonal value is 1 and then minus d is minus 2. So, which gives us a value of minus 1 and so if right. So, change in row gives us a value of minus 6, change in column gives us a value of minus 1 and then change in both row and column. So, the diagonal value is minus 2 and then coming to this row coordinate is A and then column coordinate is A. So, A versus A is again match. So, match, the value assigned for match is plus 1. So, diagonal it is minus 2. So, minus 2 plus 1 gives us minus 1. So, the three values, change in row is minus 6, change in column is minus 1, change in both row and column is minus 1. So, the maximum of these three, minus 1, minus 1, minus 6 is minus 1. Here we are getting the value of minus 1 in two directions, that is change in column as well as change in both row and column. So, that is why we are giving two arrows indicating the particular value of minus 1 obtained in two orientations, change in column I comma j minus 1 as well as change in both row and column, that is I minus 1 comma j minus 1. Similarly, the address of this particular box again it is f of I comma j. So, as we move up, that is change in row, it is minus 6. So, minus 6 minus 2 is minus 8. Similarly, as we move to the left, that is change in the column, already the value is minus 1. So, minus 1 minus 2 it is minus 3. So, change in row minus 6 minus 2 is minus 8, change in column minus 1 minus 2 is minus 3, next is change in row and column. So, the value in the diagonal box is minus 4 and then coming to the row coordinate it is A and column coordinate it is T. So, A versus T is a mismatch, the value assigned for mismatch is minus 1. So, diagonal value of minus 4 plus of minus 1 is minus 5. So, change in row, the value obtained is minus 8, change in column value obtained is minus 3, change in both row and column the value obtained is minus 5. So, the maximum of these three values is minus 3. So, minus 3 it is the value which is obtained because of change in the column. Coming to the next box, the address of this box is f of I comma j. So, change in row is the value is minus 8. So, minus 8 minus 2 is minus 10. Similarly, change in column, that is to the left the value is minus 3. So, minus 3 minus 2 is minus 5. Diagonal, so the address of this diagonal box is I minus 1 comma j minus 1. The value in the diagonal box is minus 6 and coming to the row coordinate A and then column coordinate is C. So, A versus C is mismatch. So, minus 6 minus 1 is minus 7. So, the three possible values, change in row minus 10, change in column minus 5, change in both row and column minus 7. So, the maximum of these three values is minus 5, the minus 5 is obtained because of change in the column, right. As we move to the left, the value in the box is minus 3 and gap of minus 2. So, minus 3 minus 2 is minus 5. Similarly, let us calculate the values for this particular box f of I comma j. So, the address given to this all 12 cells in the matrix, that is f of I comma j, that is the LHS of the algorithm proposed by Needleman-Wunsch, and change in row, the value in change in row box is minus 1. So, gap of minus 2. So, minus 1 minus 2 is minus 3. Similarly, change in column, the address of this particular box change in column is I comma j minus 1, value is minus 4. So, minus 4 minus 2 is minus 6. Next, change in both row and column, the diagonal value that is minus 2. Coming to the row coordinate is G and column coordinate is A. So, G versus A is mismatch, the value assigned for mismatch is minus 1, minus 2 plus of minus 1 is minus 3. So, change in row I minus 1 comma j, the value in I minus 1 box is 1 and then the gap penalty is minus 2. So, minus 1 minus 2 minus 3. Change in column, that is I comma j minus 1 value is minus 4, gap penalty of minus 2. So, minus 4 minus 2 minus 6, change in both row and column, that is the value in this diagonal box, that is minus 2, coming to the row coordinate is g and then column coordinate is a. So, g versus a is mismatch, minus 2 plus of minus 1 is minus 3, that is change in row is the value in I minus 1 comma j is 1 and then gap penalty is minus 2. So, plus 1 minus 2 is minus 1. So, the maximum of these 3 values is minus 1 and maximum of this minus 1 is obtained in the change in row. Next, coming to this next cell, the address of this cell is f of I comma j, that is the LHS of the algorithm proposed by Needleman-Wunsch, and let us calculate the 3 values in 3 different orientations. So, change in the row, that is I minus 1 comma j. So, the value in this matrix cell is minus 1. So, minus 1 minus 2 is minus 3. Next, change in column, that is I comma j minus 1. The value in this matrix cell is minus 1 and then gap of minus 2. So, minus 3 minus 2 is minus 3. Next, change in both row and column. So, the address of this diagonal box, that is I minus 1 comma j minus 1, that value is 1. Coming to the row coordinate is g and then column coordinate is a. So, g versus a is mismatch. So, the value for mismatch is minus 1. So, the diagonal value is plus 1 and then this row and column g versus a is minus 1. So, plus 1 minus 1 gives rise to 0. So, change in row, it has given us the value of minus 3. Similarly, change in column, it has given us the value of minus 3. Change in both row and column has given us a value of 0. So, the maximum of this is 0. So, this cell is filled with value of 0 and then arrow is given indicating that this particular value of 0 is obtained in this diagonal direction is because of change in both row and column. Similarly, let us calculate the value of values for this matrix cell. So, change in row I minus 1 comma j value is minus 3, gap of minus 2 minus 5, change in column. So, the value in this I comma j minus 1 cell is 0, 0 minus 2 is minus 2. Next, change in both row and column. So, this cell has a value of minus 1. So, coming to the row coordinate is g and then column coordinate is t. So, g versus t is mismatch. The value assigned for mismatch in the initialization step is minus 1. So, minus 1 plus of minus 1 is minus 2. So, the 3 possible values, change in row minus 5, change in column minus 2 and then change in both row and column minus 2. So, here minus 2 is obtained in 2 orientations, change in column as well as change in both row and column. So, this matrix is filled with a value of minus 2 which is obtained because of change in column as well as change in both row and column. Similarly, let us calculate the value of cell in this matrix table. Change in row, the value is minus 5 minus 2, it is minus 7. Change in column, value in this matrix cell is minus 2 and then minus 2, that is minus 4. Change in both row and column, the value in the matrix cell is minus 3 and then row coordinate is g, column coordinate is c. So, g versus c is mismatch, the value assigned for mismatch is minus 1. So, minus 3 plus of minus 1 is minus 4. So, change in row has given us a value of minus 7, change in column has given us a value of minus 4, change in both row and column has given us a value of minus 4. Here minus 4 is obtained in 2 orientations, that is change in column as well as change in both row and column. So, this particular matrix cell is assigned a value of minus 4 and then the 2 possible orientations, that is change in column I comma j minus 1 minus d, change in both row and column I minus 1 comma j minus 1 minus d. Similarly, let us calculate the value of this particular matrix cell, that is, so the address given to this particular cell is f of I comma j. So, change in row minus 1 minus 2 is minus 3, change in column minus 6 minus 2 is minus 8. Similarly, change in both row and column. So, the value in this matrix cell, that is minus 4 and then row coordinate is c, column coordinate is a. So, c versus a is mismatch, the value assigned for mismatch is minus 1. So, minus 4 minus 1 is minus 5. So, the 3 possible values are change in row minus 3, change in column minus 8, change in both row and column minus 5. So, the maximum of these 3 is minus 5. So, let us fill this matrix cell with minus 3 and then the possible orientation, that is possible direction is, that is change in the row. Similarly, let us calculate the value for this matrix cell. So, address given to this matrix cell is f of I comma j. So, change in row 0 minus 2 is minus 2. Similarly, change in column. So, minus 3 minus 2 is minus 5. Similarly, change in both row and column. So, the value is minus 1, row coordinate is C, and similarly column coordinate is A. So, C versus A is a mismatch. The value assigned for mismatch is minus 1. So, minus 1 that is minus 2. So, the 3 possible values, change in row has fetched as minus 2, change in column has fetched as minus 5, change in row and column has fetched as a value of minus 2. Here minus 2 is obtained in 2 orientations, change in row as well as change in both row and column. So, this cell is assigned a value of minus 2 and then the possible 2 orientations. So, the address given to this particular cell in the matrix is f of I comma j. So, change in row minus 2 it has given as a value of minus 4, change in column minus 2 has given as a value of minus 4, change in both row and column. So, the value in this cell where it is identified as I minus 1 comma j minus 1, the value is 0 and then the row coordinate is C, column coordinate is T. So, C versus T is a mismatch. So, mismatch is assigned a value of minus 1. So, 0 plus of minus 1 is minus 1. So, the change in row has given as a value of minus 4, change in column has given as a value of minus 4, change in both row and column has given as a value of minus 1. So, maximum of these 3 values is minus 1. So, this cell in this matrix table is assigned a value of minus 1 and then direction. And coming to the last cell, so the address of this particular box in the cell is f of I comma j, right. So, change in row minus 4 minus 2 is minus 6, change in column minus 1 minus 2 is minus 3, change in both row and column. So, the value in the diagonal box is minus 2 and then row coordinate is C as well as column coordinate is C. So, C versus C is a match. So, the value assigned for match is positive value of 1. So, minus 2 plus 1 is minus 1. So, change in row has given as a value of minus 6, change in column has given as a value of minus 3, change in both row and column has given as a value of minus 1. So, the maximum of these 3 values is minus 1. So, this cell is filled with value of minus 1 and then direction is provided. So, this is second step. So, the first step is initialization, second step is matrix filling, and coming to the last step, that is trace back. So, once the values are calculated for all the cells, the last step is doing trace back. So, coming to this last step, trace back, in global alignment, trace back is carried out from the last box irrespective of the value in the box. Most important in global alignment, which is carried out by using Needleman-Wunsch algorithm, in the last step, that is trace back. In global alignment, trace back is being carried out from the last box irrespective of the value in the box. So, let us start. So, the value in the last box is minus 1. So, this value of minus 1 is obtained in the diagonal direction, right, in this direction. So, the row coordinate for this particular row minus C as well as column coordinate is C. So, for this particular cell, row coordinate is C and then column coordinate is C. And coming to this box, this particular value of minus 2 is obtained in 2 directions, change in column as well as both change in row and column. For a particular box, if the value is obtained in more than one direction, then priority should be given to the cell where there is change in both row and column. So, the row coordinate for this particular cell is G. Similarly, the column coordinate for this particular cell is T. Right. So, coming to this particular value of minus 1 in this particular cell is obtained again in 2 directions, change in column as well as change in both row and column. So, let us presume this. So, for this particular cell, it is in the same cell. So, there is no row coordinate, but there is a column coordinate. Since there is no row coordinate, So, we are going to fill it up with gap, and then coming to this particular last cell. So, this value is obtained in the diagonal direction. So, the two coordinates for this particular cell are A and A. Right. So, in the initialization step, we have initialized positive value for match of 1, mismatch of -1, and then gap of -2. So, C versus C is a match of 1, mismatch, gap of -2, match 1, right. So, it is as simple as +1 -1. So, finally, right, the calculated value is equivalent to the alignment value. So, if calculated value and alignment value are one and same, then we have executed this alignment perfectly. Third step in this is the trace back. So, as we have seen in the previous slide. So, in backward tracking, we have to move from the last cell. In global alignment, trace back is being started from the last cell irrespective of the value in the box. So, backward tracking, in backward tracking, we have to move from the last cell and follow arrows from which the cell, the current cell values come from, and go ahead till this origin. So, here we can see two paths, path 1 as well as path 2, whether it is path 1 or path 2, calculated value should be equal to the aligned value. So, here calculated value is -1, should be equal to the alignment value. Now, we have to align the sequence. For aligning, there are two rules. If the value come from column, we will have to write two sequences. So, the value come from horizontal or vertical, then we have to write perpendicular, add gap to other side. So, here we can see two alignments. Let us calculate. So, C versus C match of 1, T versus D mismatch of -1, A versus A match of 1, and then gap of -2. Similarly, C versus C match of 1, gap of -2, mismatch -1, and then match 1. Coming to the second alignment, that is local alignment. So, as we have seen in the first slide, previous slide, dynamic programming, it is carried out in two orientations. The first one is global and second one is the local. So, global alignment is carried out by using Needleman-Wunsch algorithm. Similarly, local alignment is carried out by using Smith-Waterman algorithm. So, the only difference between these two alignments in traceback step is, in global alignment, traceback we are going to do it from the last cell, but whereas in local alignment, traceback is going to be done from the box with highest value. It is nothing but the maximum value, the only difference between global and local. So, coming to this local alignment, which is carried out by using the algorithm proposed by Smith-Waterman, and there are 4 conditions, right. So, the first one is change in both row and column, second one is change in row, and third condition is change in column, and fourth condition is this one. This 0 we are going to call it as predefined 0. So, we are going to take care of this value once all these 3 gives us negative values, change in both row and column, change in row as well as change in column, where I denotes rows and then J denotes columns. So, the first condition is change in row and column if it gives negative value, second one is change in row, that is I minus 1, third condition is change in column J minus 1. If all these 3 gives a negative value, then we are going to pick this predefined 0. So, coming to the summary. So, global alignment is nothing but alignment of a pair of sequences along their entire length, right. So, trace back with respect to global alignment is done from the last box, lower right corner we call it as last box, irrespective of the value in the box, right. So, the algorithm used for global alignment is Needleman-Wunsch algorithm, and they have given 3 conditions. The first one is row change, second condition is column change, third condition is both row and column change. Coming to this local alignment is defined as alignment of a pair of sequences along their conserved regions, mainly used in phylogenetic studies. With respect to the traceback in local alignment, traceback is done from the box with the highest value. These are the possible questions. The first question is all about explain about the concept of dynamic programming, and then second is about Needleman-Wunsch algorithm, third one is about Smith-Waterman algorithm, and then performing global alignment for these 2 strings, similarly performing local alignment for the 2 strings, and then performing global alignment for these 2 strings, similarly local alignment for these 2 strings. So, the difference between these 2 is nothing but, as we know, we have 2 types of sequences. First one is nucleotide sequence, second one is protein sequence. So, as we know, nucleotide sequence is repetition of 4 bases: adenine, guanine, cytosine, thymine if it is DNA. Similarly, adenine, guanine, cytosine, instead of thymine you will have uracil if it is RNA. Similarly, the second set of sequence is the protein sequence. As we know, protein is a polymer of 20 amino acids, where each amino acid is coded by a single alphabet. So, these 2 strings, they are with respect to nucleotide sequence, and these 2 strings, they are with respect to proteins. They are the references. So, the standard reference, first one Zin-Xiong, and then David Mount, Atwood and Smith, and then Lesk. So, the possible reference books, first one Zin-Xiong, second one is David Mount, Atwood and Smith, and last one is Lesk. These are the 4 standard reference books, textbooks which are used for this particular topic. Thank you.